Hello everybody, this is Michael. In this video, we will talk about the ESP32 PICO Wi-Fi Bluetooth chip introduction. Okay, so for the ESP32 PICO chip, it has three chips. One is PICO D4. Another one is PICO V3. Another one is PICO V302. Okay, so for the three chip, most of the function is the same. The difference is flash, PSRAM, and a few GPIO do some adjustment. Okay, it has some adjustment for some GPIO. So we will use the PICO D4 for our board. Okay, this is the classic PICO chip. Okay, so for the ESP32 PICO D4, let's take a look what function it has. Okay, let's take a look at the overview first. So this is an overview. This chip is a system in package. It includes lots of other components inside the chip. Okay. First, this chip is based on ESP32. Provide the Wi-Fi and Bluetooth function. Okay. The size is very small. It's 7 by 7. Okay. Millimeter. And this chip is already included one 4 meg SPI flash. Okay, included one 4 meg SPI flash. It includes lots of components: crystal, flash, filter capacitor, and RF matching link in one single package. It means we can design the PCB board is more simple than before. Okay, it's also very good for our solder and testing. Okay, it's much better. So it's very good for space limited or battery operate application. Okay, so here it tells us what the chip what the function the chip will have. Okay, so first, of course, is a Wi-Fi, Bluetooth, and it has the ADC, DAC, touch sensor, SD. This is SD card interface, SPI. You can connect any SPI sensors. Okay, SDIO and PW and UR and I2C, I2S, and the infrared remote controller, and the 2-wire automotive interface, Hall sensor, and crystal, 4 meg flash. Okay, so it is a very powerful chip. Okay, for this chip, the power supply is from 3.0 to 3.6. So we can use 3.3 power supply, like one LDO The current is average is 80 milliamp. The minimum current so delivered by the power supply is 500 milliamp. So we can use one LDO to power the chip. There is lots of LDO we can choose. We can choose a very small size one, okay, for this current. So next, this is a pin layout for the chip. This pin is for the ground, is on the bottom of the chip, so connect to the ground. So here is the detailed description for each pin. Okay, power supply here, and ADC each channel 0, 1, 2, 3, 4 channel. Okay, this is RTC. Okay, this is enable. This is ADC. Okay, DAC. ADC channel, ADC, okay, and this is RTC here, RTC, and this is UR2, this is UR, this is SPI, this is SPI, clock, and CS. And this is UR0. This is UR0. Okay. Okay, here this is the strapping pin. This pin is for the system boot. So for the system booting, okay, the booting mode. So how we control the voltage on this GPIO, and then we can boot in the system. Okay, so this is the system booting GPIO, and here this is internal memory. It also can connect the external flash and SRAM. Okay, the crystal is already included in the chip, is 40 MHz. For the RTC and the power consumption, so we can reference the ESP32 datasheet. Okay. Also, for other function, it also share with the ESP32. Okay. So because inside the chip, the main CPU is still the ESP32. Okay. So here is the power supply voltage. The maximum is 3.6 volt. Okay. Typical one is 3.3 volt. Okay. So here is Wi-Fi, the Wi-Fi permit. Okay. And this is a Bluetooth permit. Okay. This is reflow temperature. How we control the reflow for the chip. Reflow temperature profile. Okay, so this is a schematic inside the chip. You will see here. This is the ESP32. Okay, inside the chip. It includes the crystal. Is this one? This is the crystal, and it includes the flash here. So this is the flash. It also includes the RF link. So it's here, the RF match link. It includes lots of filter capacitor, something like this. Okay, so is we can easily design the circles for the chip. And this one is minimal system chip, minimal system schematic for the chip. So this is the PICO chip here. We added a reset button, and we added voltage, and this is UR. This is UR here. Okay, you can connect one outside PS ring here. For some application, we don't need this one. Okay, we don't need this one. Okay. So this is a package information. This is 7 by 7. This is D, and this is E. The D is here. Okay, so this is 7. The E is here. This is 7. 7 by 7 millimeter. So this is millimeter. It's very small. Okay, it's very small. It's a wonderful chip. This is a PCB footprint. Okay, PCB footprint. So how you design the footprint for your board according to this parameter. Okay. Okay. So this is other resources, and is good for our board design. This is hardware resource, the hardware design guideline. Okay, and this is GitHub, and this is tools. Okay, so this is datasheet for our PICO D4. For the latest one is PICO V302. For this one is including the main feature is this. Okay, the main feature is this. It includes 8 SPI fresh, another 2 SPI PS ring. So this is include 8 SPI fresh. This is 2 SPI PS ring. Okay, so this is for this V302 is more powerful. Okay, so V3 for V3 is still 4 meg SPI fresh. Okay, the difference between the V3 and the D4 is here. So you can see the difference is here. This is PICO V3. This is PICO D4. The difference for the GPIO. Okay. So this is a very new product, and it's very similar to D4. Okay. It's possible to update this one. Okay. To replace this one. Okay. So for the V302, the difference is here. Okay, you can see this is V302, and this is V3, and this is D4. Okay, this is the difference is here. So some pins difference. Okay. This one is the latest one, and include the fresh and PS ring is 8 meg. This is 2 meg. Okay, and this one, the V3, impossible to connect with PS ring. It means no any connector for the PS ring, but for D4 it is possible to connect with the PS ring. Okay, the fresh for this one and this one is the same. For me, this one is like a cost down version for the D4, but this one is a powerful one. It's a This one is more powerful ESP32 PICO chip. Okay. So the difference for the three chip is here. Okay. So for our board, for our the Wi-Fi Bluetooth DIY board, for our board, we will use the D4 as our main chip, because if we can drive this chip, also we can drive another two chip. So we can drive this chip and this chip. So so this is for this video, and the next let's take a look at the schematic for the board, for the DIY board. So see you next time. This is Michael. See you next time.